Hello there. Let's talk today about some graphing techniques. Now I know when I cover these graphing techniques, you're going to want to use your calculator to graph whenever possible, but it's actually good to understand this because this will help you understand the algebra of functions that we'll talk about later. So let's talk about some of these techniques. The first such technique I'm going to talk about is a vertical shift. Basically what this does is, let's say you knew what the graph of some function f of x looked like. Okay, like one of those basic ones we talked about, like x squared or square root of x. If you add a number to that graph or to that function, all it does is shift the graph vertically upward. And then if you subtract a number from that graph, all it does is shift it vertically downward. And for instance, if you wanted to graph this function, x squared plus 2, well, it has a parent function, or a mama function, I would say. And let's say the mama function, looking at this, it looks like the mama function would be the function f of x equals x squared. And we know how to graph this function. So since we know how to graph this function, we can easily graph this function up here because it's just this function plus 2 units. So therefore, all we have to do is shift the graph of this up 2 units. Okay? And that's it. Likewise, if you wanted to graph the square root of x minus 4, then the first thing I would do is I'd say, okay, this is probably a child of the square root function, so its mama must be the square root function. And then I would realize I'm subtracting a number from it, so that means it's going to shift the graph down that many units. And just give me a second here. Of course, it won't be a second. It'll be just a second to you. But I'll set up these graphs and let you take a look at them and see how they work. So let's take a look at what would happen with x squared plus 2. Okay, so this is the graph of x squared. You see it over here. Basically what's going to happen, you remember there's several reference points we use, like -1, 1, -2, 4, and so forth. And then 1, 1, and then 2, 4. Well, all you're going to do when you graph x squared plus 2 is you're going to take this point, -2, 4, and you're going to shift it up 2 units. You're going to take this point, shift it up 2 units. You're going to take this point, shift it up 2 units. You'll take that point, shift it up 2 units. And then you'll take that point, shift it up 2 units. And then if you were to draw the graph through that, then it's going to look like that. And so, see, the vertical distance between this graph and this graph is just 2 units, because all you're doing is adding 2 units to all the y values, and so therefore it's going to lift the graph upward 2 units. So as long as you know how to graph y equal x squared, then you can graph y equal x squared plus 2, or y equal x squared plus 5, or y equal x squared plus 8, or y equal x squared minus 5, or minus 1, whatever. So you just have to know to shift it up or down in that case. Okay, the other picture, we had square root of x. Okay, so here's square root of x. And when we graph square root of x, we had to use like 0, 0, 1, 1. And then we went out here and got 4, 2. And we can probably get a decent graph with just those 3 points. But since this is square root of x minus 4, what's going to happen is you're going to shift this point down 4 units, and it's going to be here. Then you're going to shift this point down 4 units, and it's going to be here. And then this point's going to shift down 4 units, and it's going to be here, and so forth. And so when you do that, this is the graph that you're going to get. So this is the graph of y equals x squared minus 4. And again, as long as you know how to graph this is the graph of y equals square root of x minus 4. And as long as you know how to graph y equals square root of x, then you can graph y equals square root of x minus 4. You can graph y equals square root of x plus 4. You can graph y equals square root of x plus 8. and so forth. So you can graph basically any variation of square root of x where you add a constant to it. So whatever the constant's added to it, if it's a positive number, you shift it up. If it's a negative number, you shift it down. And that's basically how vertical shifts or vertical translations work. Now the horizontal shifts are a little bit more difficult to understand because rather than adding a constant, what you're doing is you're actually replacing x with a constant. Actually, let me start again. You're replacing x with x plus a constant or x minus a constant. So it turns out that if you want to graph a function where you replace x with x plus a constant, this is actually a horizontal shift to the left. And so you might think it would be to the right, but it's actually to the left. And there's really a reason for that. I'll show you in a minute. Okay, now, if you replace x with x minus a constant, it's going to be a horizontal shift to the right. For instance, if you look at this function, x minus 3 quantity cubed, it's really this function, x cubed, except that x has been replaced with x minus a constant. So as long as we know how to graph x cubed, then we can graph the quantity x minus 3 cubed by simply shifting the function to the right 3 units. And here's another one, the absolute value of x plus 4. Okay, now notice this is a little bit different than these were up here. Like here, the minus 4 was outside the square root, the plus 2 was outside the square. Here, the plus 4 is inside the operation. So, and the mama function for this would be the absolute value function. So what we've got up here, what this function is this function is actually this function with the x replaced with x plus 4. So in other words, this is like saying this function evaluated at x plus 4. And so if you take a function and evaluate it at x plus a constant, then that's going to be a shift to the left. And in this case, since it's 4, it's going to be a shift to the left 4 units. And I'll show you that on the graph. Okay, so here's the graph of y equals x cubed. Okay, now notice the point 0, 0. Let's just focus on 3 points. 0, 0, negative 1, negative 1, which is about right there, and then the point 1, 1. Let's just focus on those 3 points. Okay, we know we need to shift those 3 points based on this to the right 3 units. So if I were to shift this point, let's start up here. If I was to shift this point to the right, I'd get 3 units. I'd get a point right there. If I shift this to the right 3 units, I get a point right there. If I shift this point to the right 3 units, 1, 2, 3, I get a point right there. So basically, we're looking at something that kind of goes through here like that. So it's the same shape, but it's just shifted to the right 3 units. Okay? All right. Now, you might ask, okay, why does it shift to the right? Well, notice that x cubed, when does y equal 0 for x cubed? When is y 0? Y is 0 when x is 0. But think about this one. When is y going to be 0 for this one? It's going to be 0 when x is positive 3. So basically, the point 0, 0 has to be shifted over to the point 3, 0. You see? So 0, 0 gets shifted over to the point 3, 0. So that's why it gets shifted to the right. Okay? Now the other one I showed you was absolute value of x. And this is the graph of absolute value of x. Now, when you graph absolute value of x, you really don't need a whole lot of points. You just have to know where this little vertex is right here. And then you can like just pick any point over here, like that's negative 5, 5. Ignore what it says, just pretend like that's negative 5, 5. And then this is positive 5, 5. Now, this right here is telling me, since I've got that function with x is replaced with x plus 4, then to get this graph, I've got to shift it 4 units to the left to counteract that. So what's going to happen is this point right here is going to move 1, 2, 3, 4 to here. Then this point's going to move 1, 2, 3, 4 to here. And then this point's going to move 1, 2, 3, 4 to here. And so now I don't know exactly where I was. I think I was here, and then you're going to come down here, and then you're going to go up through there, I believe. But anyway, so there's the black graph is the new one. So that's the new graph. And again, notice that for the original function, y equal absolute value of x, y is 0 when x is 0, right? But for this function, when is y 0? It's 0 when x is negative 4. So you can see that, what would it take to make this part equal 0? It would take a negative 4. So the point 0, 0 gets actually shifted to the left to negative 4, 0. And so that's true of all the points. All the points get shifted 4 units to the left. And again, going back to what I said earlier about vertical shifts and horizontal shifts, like if I wanted to graph x plus, let's say x plus 2, well, that's just going to shift 2 units to the left. X plus 5, that's going to shift 5 units to the left. Okay? And then if I went the other way and said minus 5, it's going to shift it to the right. X minus 5 is going to shift it to the right. Or x minus 3 is going to shift it to the right. And I could show you the same thing with these up here, but hopefully you get my meaning now on these horizontal shifts. So when you replace x with x minus a number, it's going to shift that function to the right that many units, 3 units in this case. If you replace x with x plus a number, it's going to shift this function 3 units to the left. So that's how it works. And let's see. Oops. All right, so let's shut this video down right here on vertical shifts and horizontal shifts, and then let me pick back up on the next video, continuing section 2.3 here, and talk about some other graphing techniques. And make sure you go through all of these graphing techniques before you actually try to go out on your own and graph these functions.